Hello and welcome to part 3 of the mechanics toughest questions for Edexcel International A-level series that I'm doing, where in this question we tackle lots of questions that are not repetitive and are having a very difficult idea. Basically the A-star questions, the question that determine if you pass with the grade you want and the A-star or no. So we will take a look at this question from Jan 24. This is basically question 7. So as we can see, this is a vectors question. So for question 7, it says that in this questions, I and j are horizontal unit vectors. So I, as we know, is unit vector to the right, and j is a unit vector upwards. Okay, so it says due east and due north respectively, and position vectors are relative to a fixed origin O. So this is the O, and any position vector is relative to this point. Okay, this is basically the first sentence. So it says, at midnight, a ship S is at a point with a position vector of 19I plus 22J. So we start at midnight. This is where, let's say, our time equals 0. Okay, it was at midnight. Nothing has passed. We start to look at the question from midnight. So time equals 0 at midnight. And the ship is at a position vector of, if we draw this, it's going to be position vector of 19I. Say this is 19, this is I, this is j, 19I and 22j. Let's say this is 22. So S is here, and this is the position vector from O to S. Okay, so it says that the ship travels with a constant velocity of 12I minus 16j. What does this mean? It means that the position of the ship at t equals 0 is here. And it's not still, it's moving. How is it moving? It's moving at a velocity with this vector, 12I and minus 16j. So it's basically moving in this direction, moving 12I and minus 16j. So this is 12, this is 16. So it's moving in this direction with these magnitude. This is the v of the ship. So it will keep moving, and when it comes here, it's going to continue moving in this direction and so on. Okay, so the question wants us to find the speed of S. So I know that this is the velocity vector. Okay, so I know that speed is scalar, so speed is the magnitude of velocity, and let's call this velocity vector v. So if I want the speed, is going to be the magnitude of v, and I know to find the magnitude, it's basically equal to square root of the I component squared adding the j component squared. This is going to give me an answer of let's do square root of 12 squared plus 16 squared. That is going to give me an answer of 20. And what is my unit? Kilometers per hour. So this is part A. Okay, let's take a look at part B. At time t hours after midnight, the position vector of S is small s kilometer. So there is a general expression showing me the position vector of S at any time t. So this vector is supposed to be something in terms of t, where I will substitute any t I want. So if I want to look at the position vector after 1 hour, I will substitute t here with 1, do the calculation, and it will give me the position vector of the ship after 1 hour. If I want to see after 1.5 hours, I will replace t with 1.5 and so on. So I need this general position vector. So as we all know that the general position vector, okay, equals the initial position vector at time t equals 0 plus the velocity vector times time. We all know and work with this, but I would just like to take 2 minutes to tell you where did this come from. We know that the velocity vector is 19I plus 22j, okay? We know that the velocity vector is v, okay? So, and we know that S is basically the position or displacement. And I know that displacement is basically the integration of velocity with respect to time. So if I try to integrate this, okay, I will have v, which is a constant, anything, a constant integrated with respect to t, it will be basically vt. And then I will need to have the constant of integration plus c. So I know that at t equals 0, okay, my position was 19i. Sorry, the velocity is not 19i, the velocity is 12i minus 16j. Okay, but at time t equals 0, the position vector was 19i plus 22j kilometers. So I know when I substitute t with 0, okay, s should equal 19i plus 22. So 19i plus 22j equals v times when time is 0 plus c. So this cancels, and this shows me that my c is basically 19i plus 22, which is my initial position vector, which is s0. And from here, we can tell that s is going to equal vt plus c, which is s0, or basically this expression, which is the initial position vector plus vt. Okay, I hope this is clear. So let's move on from here. This was just a side note. It's very important to understand the concepts for your further studies. Okay, so continuing from here, to find this position vector, we will say that s equals s0, which was 19i plus 22j, plus the velocity vector times time. So the velocity vector was 12i minus 16j, so 12i minus 16j times time. Or I can rewrite this grouping the i's together. I know that the I will have a 19, and then adding 12, which is this 12 multiply t, so adding 12t. This is the this is going to be the I component, and then adding to it the j component, which is similarly going to be 22, and then minus a 16t j. So this is basically my s position vector, any general position vector. If I want the time or the position vector at any time, I will just substitute my required time in t and find s. Okay, so continuing from here, a lighthouse, it says a lighthouse stands on a small rocky island. The lighthouse is modeled as being a point with a position vector of 26i plus 15j. So it says it is not safe for ships to be within 1.3 kilometers of the lighthouse. Okay, so the distance, not displacement, the distance from the lighthouse to the ship should be more than 1.3 kilometers to be considered a safe distance. Okay, CI says find the value of t when s is closest to the lighthouse. Right. Let's think about what's happening here. We have our position vectors, okay, and we have a lighthouse that is still, it's not moving. It's at a position vector of 26i plus 15j. So let's say around here, this is 26, this is I, this is j, and this is 15. Okay, so this is the lighthouse. The ship is somewhere, but it's moving every single hour or every single time it's moving. Okay, so maybe it's moving at a constant velocity, so it's moving like this. Okay, so every single time, let's say this was at time t equals 0, this was the ship. At time t equal 1, the ship was here, and so on. So the distance between the lighthouse and the ship when time equals 0 is this. The distance between the lighthouse and the ship when time was equal to 1 is this. So we can see that I need to find that what is the closest distance that the ship is going to be to the lighthouse. So basically what I want is I want the distance from the vector or the expression that will show me what is the distance between the ship and the lighthouse at a given time. So in order to find that, I know that I can find the distance between the ship and the lighthouse is basically a vector, which is going to be, let's say, SL. Okay? So we know that SL equals the L vector minus the S vector. So let's see how we can derive that. So the L vector is 26i plus 15j. We have a 26i plus 15j minus the S vector, which is the vector I just got from the previous part. So it's minus 19. Let's take this 19i plus 12t I as well. Okay, or I can rewrite it as, okay, let's use this form. So 19i plus 22j plus 12i minus 16j t. So basically I need to perform this subtraction. So I will have a 26i. Let's do the i's first. So for the i's I will have a 26 minus 19 minus 12t. So 26 minus 19 minus 12t. This is the I component. And similarly, for the j component, I'm going to have a 15 minus 22. And then minus times minus 16 is going to be plus 16t in the j. So basically, SL is going to be a vector with 26 minus 19, that is 7 minus 12ti plus 15 minus 22, that is minus 7 plus 16t in the j. So this is basically the vector which shows the displacement between S and L at any given t. So if I want to check what is the displacement when t equals 1, I will plug in 1 here, and it will give me the vector which shows the displacement. But here, I want to find the distance. I want to find the distance between them, and we know that the distance is basically the magnitude of the displacement vector. So it's basically a big square root with the I component squared plus the j component squared. So this is basically the displacement, the distance. Okay, so this is the distance between S and L. So if we continue from here, let's expand. So I know that 7 minus 12t all squared is basically square of this first, which is 79, and then first times second times 2, so 7 times negative 12 times 2 is basically negative 168, and we have a t. And then negative 12t squared is basically plus 144t squared. Let's do the same for the other binomial. So it's going to be plus 49, and then negative 7 times 16, that is negative 112, times 2, that is negative 224t, and then 16 squared is basically plus 256t squared. So let me add the like terms together. So I will have an expression that looks like, so I'll have a 49 plus 49, that is around 98. Actually, let me add the t squared first, so it looks nice. So I will have a 144 plus 256, that is 400 t squared, and then let's add the t. So I have a minus 168 minus 224, that is minus 392t, and then I have a 49 plus 49, which is plus 98. So basically, this is my distance. So if I want the actual magnitude of the distance, I will substitute any time and check the distance at that time. But the question wants, what is the value of t when S is closest to the lighthouse? So when S is closest to the lighthouse, it means that the distance between them is the minimum it could get, right? And from application of differentiations, we know that when we want to find the minimum or a maximum of something, we can use differentiation and then equate it to 0 to get the critical points. So what we can do is that we know that the minimum for this thing means that the minimum, that the thing under the square root, this expression under the square root, should be a minimum. So if I want to look at the differentiation of the expression under the square root, is going to be something like this. So let's say dy by dx, this thing is going to equal dy by dt. We're differentiating with respect to t. So it's going to be 800 t minus 392. This is going to be the differentiation. And in order to find the critical points, I will need to equate my differential equation here, this differentiation or this derivative. I will need to equate it to 0 to find the critical points, which are either a minimum or a maximum. So if I solve for t, then I will divide by 800, divide by 800. T is going to equal a value of 0.49 seconds. So this is where my critical point is. This is where my minimum or maximum happens. So since it's only one value and the question asks for a minimum, it must be a minimum. But for you to be sure to know that this critical point is it a minimum or a maximum, we get the second derivative, which is going to be the differentiation of this expression, which is basically going to be 800. And then we check if this second derivative, when we put in t in this second derivative, is it going to give us a positive value or a negative value? Since here it's only one number with no ability to put a t in, it's basically saying that my second derivative is always positive. And I know when the second derivative is positive, it means that my values are a minimum. So I know that this time is where the distance is going to be minimum, and this is going to be my answer. So for part CI, determine whether it's safe for S to continue its course. So our condition for safety was that the closest they can be together should be at maximum 1.3 kilometers. They cannot be closer than this. Okay, so let's see the point or the time where they're closest together, which is 0.49 seconds. How much was the actual distance between them? So to know that, we need to put our t in our displacement or distance equation. So our distance equation was square root of 400 times t squared, so 0.49 squared, and then minus 392 times t, which is 0.49, and then plus 98. And when we check our calculator to try and compute this, it's going to be an answer of is going to give us an answer of 1.4 kilometers, meaning that the minimum, the closest they will be, is 1.4 kilometers. So it's very safe for the ship to, it will be always safe because it will never get closer than 1.4, and 1.4 is greater than the minimum distance required, which is 1.3. So it will always be safe for the ship to continue its course. Please feel free to subscribe, like, and comment down below. I would suggest you to suggest any topics or any questions you would like me to go through next. And please stay tuned for more. Put on the notification buttons, kindly subscribe, and thank you so much for watching.